Stonehenge, perched on the windswept plains of Salisbury in southern England, has fascinated historians, archaeologists, and travelers for centuries. Its iconic arrangement of massive standing stones, some weighing as much as 25 tons, forms a circular monument whose purpose and construction continue to inspire awe and debate. Despite decades of research, many aspects of Stonehenge's origin remain enigmatic. Why was it built? How were these colossal stones transported and erected? And what knowledge or technology did its builders possess that allowed them to accomplish such a feat in the Neolithic period? Constructed in several phases over thousands of years from roughly 3000 BCE to 2000 BCE, Stonehenge is more than a collection of stones. It represents an intersection of engineering, astronomy, and ritual practice. The earliest elements, including the circular earthworks and timber posts, evolved into the stone structures that define the site today. The monument's sophisticated layout, including precise alignments with solstices and other celestial events, suggests that its builders possessed advanced understanding of geometry observation and the cyclical patterns of the sky. Each stone seems purposefully selected, placed, and oriented to convey significance beyond mere construction. The sheer size of the stones, particularly the larger sarsens, presents an enduring logistical mystery. Sarsens, some standing over 7 meters tall, had to be quarried, transported over 30 kilometers from the Marlborough Downs, and carefully raised into position without modern cranes or vehicles. Even the smaller bluestones transported from the Preseli Hills of Wales over 200 kilometers away represent a monumental challenge. The coordination, effort, and ingenuity required for such an enterprise point to a society with highly organized labor, intricate planning, and intimate knowledge of materials and terrain. Yet despite their apparent mastery, many questions remain unanswered. How did Neolithic people achieve precise vertical placement? How did they transport stones over long distances without wheels, pack animals, or steel tools? Did they employ mechanical innovations now lost to history, like the mysteries of the pyramids or Moai statues? Stonehenge challenges our assumptions about prehistoric capabilities, suggesting that the ancients may have possessed knowledge and skills far exceeding what modern observers have traditionally credited them with. Recent discoveries have begun to shift our understanding, uncovering evidence of complex engineering techniques, advanced knowledge of stone properties, and potentially lost methods of moving and erecting these massive blocks. These findings compel us to reconsider the narrative of prehistoric limitation, hinting that the builders of Stonehenge were not only laborers or shamans, but also sophisticated engineers who combined observational science with ritual social organization and practical ingenuity. The story of Stonehenge, like the monuments of other ancient civilizations, is thus a story of human creativity, persistence, and the enduring quest to shape the environment according to cultural and spiritual imperatives. For centuries, one of the most compelling questions about Stonehenge has been how its builders managed to move and erect such enormous stones across considerable distances. The larger sarsen stones, some over 7 meters in height and weighing up to 25 tons, were quarried approximately 30 kilometers away from the Marlborough Downs. Even more astonishing are the bluestones, which originate from the Preseli Hills in Wales more than 200 kilometers away. Transporting these stones without wheeled vehicles, draft animals, or metal tools poses a formidable logistical problem that continues to challenge archaeologists and engineers alike. Traditional theories have suggested several potential methods. One idea is that stones were dragged on wooden sledges over lubricated tracks, possibly greased with animal fat or water to reduce friction. Teams of dozens or even hundreds of people could have coordinated their effort using ropes and pulleys made from natural fibers. However, experimental archaeology indicates that moving the largest stones in this manner would have required extraordinary precision to prevent cracking or toppling, especially over uneven ground and steep inclines. Another prominent hypothesis proposes the use of roller systems where cylindrical logs were placed beneath each stone to facilitate forward movement. While this method seems plausible over short distances, transporting the bluestones over 200 kilometers of rivers, hills, and forests would have necessitated a level of planning and coordination beyond simple improvisation. The logistical challenges extend beyond the physical act of moving stones. Pathways needed to be cleared, materials for rollers had to be sourced in large quantities, and teams had to remain synchronized across hours or days of labor. A more recent and intriguing proposal involves rocking the stones upright in a controlled motion, leveraging careful balance and strategically placed supports. This method, although requiring extreme skill, could allow a single team to incrementally advance a stone while minimizing the risk of structural damage. Such techniques highlight the potential that Neolithic people may have possessed empirical knowledge of leverage torque and center of mass, applying it effectively without written formulas or advanced machinery. The mystery deepens when considering the erection of the stones into upright positions and their precise alignment within the circular monument. Raising a 25-ton sarsen from horizontal to vertical would have required scaffolding ropes and a well-coordinated sequence of force applications. Experimental reconstructions show that by building inclined planes or earthen ramps, ancient builders could gradually slide and pivot the stones into position, achieving stability and alignment with remarkable accuracy. The precision of the monument's arrangement, particularly its astronomical alignments, implies not only technical skill but also careful observation, planning, and repetition, suggesting that the builders had a sophisticated grasp of both engineering and spatial awareness. Thus, the mystery of Stonehenge's stones extends beyond raw physical effort. It encompasses knowledge of mechanics, material properties, coordination of large groups, and the ability to plan complex operations over long distances. Each potential solution, whether sledging, rolling, rocking, or ramping, provides a glimpse into a society capable of applying empirical engineering principles, demonstrating ingenuity that challenges conventional assumptions about Neolithic technological capability. Stonehenge, in this sense, remains a testament to human creativity and problem-solving, an ancient puzzle whose pieces continue to reveal themselves through careful study and experimentation. Over the years, scholars have proposed a variety of traditional hypotheses to explain how the Neolithic builders of Stonehenge might have moved and erected its massive stones. The earliest theories, dating back to the 17th and 18th centuries, suggested that simple brute force and large numbers of people were sufficient. Teams of workers could have dragged stones over wooden sledges along cleared tracks, using rope tension and sheer human strength to overcome friction. Such approaches, while feasible for small stones, leave many questions about the larger sarsens and the far-traveling bluestones. By the 20th century, engineers and archaeologists began experimenting with alternative methods. Roller systems using logs as cylindrical supports beneath the stones were tested with scaled replicas. Experiments demonstrated that stones could indeed be moved this way across flat terrain, although steep inclines and uneven ground posed serious hazards. The need to replace logs continually, as well as to coordinate large teams over long distances, emphasized that careful planning, labor organization, and sustained effort were essential to success. Another intriguing approach focused on the use of levers, pivot points, and inclined planes. Experimental archaeologists built wooden frameworks that allowed heavy stones to be gradually rocked and raised incrementally. Such methods reduce risk by distributing weight and enabling precise control over movement. This approach is supported by traces found at some quarry sites where depressions and aligned stone fragments hint at deliberate mechanical strategies. The techniques also suggest that builders may have conducted systematic trial and error learning, passing down effective methods across generations. In the last 2 decades, scientific investigation has provided new insights. Material analysis of the bluestones indicates that some were quarried using primitive but sophisticated stone tools, leaving tool marks consistent with controlled fracturing. Geochemical studies have mapped the precise sources of the stones in the Preseli Hills, revealing not only the origin but likely transportation routes. LiDAR and high-resolution topographic mapping have uncovered subtle ridges and depressions along potential paths, providing evidence that terrain may have been modified to facilitate movement. These discoveries lend credibility to modern reconstructions and highlight a combination of technical ingenuity and environmental adaptation. Experimental archaeology has played a particularly revealing role. Full-scale replicas of sarsens weighing between 4 and 10 tons have been moved by small teams using combinations of ropes, levers, and rocking motions. Researchers documented the amount of force required, the coordination of effort, and the precision necessary to avoid toppling. Some trials achieved movements of several meters per minute, demonstrating that while challenging, such feats were within the capability of organized Neolithic communities. These experiments underscore that success depended on accumulated knowledge, empirical problem-solving, and careful social coordination rather than luck or brute force alone. Together, traditional hypotheses and modern scientific approaches provide a framework for understanding Stonehenge's construction. They suggest a society capable of combining empirical engineering, logistical planning, and sophisticated coordination with ritual and cultural imperatives. The evidence increasingly supports the notion that the builders were not simply laborers, but highly skilled practitioners, capable of solving complex technical problems and executing monumental projects that continue to challenge contemporary understanding. Recent discoveries have begun to change our understanding of Stonehenge, suggesting that its builders employed techniques far more sophisticated than previously imagined. Archaeologists and engineers have combined traditional fieldwork with cutting-edge technology, including LiDAR scanning, geochemical analysis, and high-resolution mapping, to uncover previously hidden features of the landscape surrounding the monument. These studies reveal that the movement and placement of the stones were likely guided by a combination of empirical engineering and environmental manipulation. One significant breakthrough concerns the transportation of the bluestones from the Preseli Hills in Wales, over 200 kilometers away. Geochemical fingerprinting confirmed that these stones originated from specific outcrops, allowing researchers to reconstruct probable transport routes. Analysis indicates that the Rapa Nui-style rolling and sledging techniques may have been enhanced by carefully constructed pathways, partially cleared forests, and strategically leveled ground, minimizing energy expenditure. This suggests that prehistoric communities were capable of large-scale environmental modification to support monumental construction projects. Experimental archaeology has played a pivotal role in testing these hypotheses. In the United Kingdom, teams have successfully moved full-scale stone replicas using a combination of sledges, wooden rollers, and controlled rocking techniques. By employing ropes woven from natural fibers and coordinated effort among dozens of participants, researchers demonstrated that even the heaviest sarsens could be transported over several meters at a time without mechanical failure. Force measurements during these trials highlight the importance of balance synchronization and gradual incremental movement, mirroring what would have been required for the actual stones at Stonehenge. Another remarkable discovery involves the alignment and placement of the stones within the monument. High-resolution surveys indicate that the builders achieved astonishing precision in arranging sarsens and bluestones relative to each other and to astronomical markers such as the midsummer sunrise and midwinter sunset. Such alignments imply not only advanced observational skills, but also a deep understanding of geometry and spatial planning. The precision challenges the notion that Neolithic builders were solely guided by ritual or symbolic intent. Their work reveals a practical and methodical approach to problem solving. Material analysis has uncovered further insights. Tool marks on the stones suggest controlled fracturing techniques, enabling the Rapa Nui to shape massive rocks with surprising accuracy. Experiments replicating these methods demonstrate that primitive stone hammers and chisels could indeed produce the shapes required for transportation and fitting within the monument. Combined with knowledge of leverage friction and weight distribution, these techniques provide a coherent explanation for how stones could be raised and aligned with minimal technological resources. Collectively, these new discoveries transform our understanding of Stonehenge. Far from being a construction achieved by guesswork or simple brute force, the monument reflects a sophisticated combination of empirical engineering, strategic planning, environmental adaptation, and communal effort. The evidence suggests that the builders were highly skilled problem solvers who applied systematic knowledge to overcome immense logistical challenges, integrating practical techniques with cultural and ceremonial objectives. Stonehenge therefore stands not only as a testament to prehistoric ingenuity, but also as a reminder that careful observation and interdisciplinary research can reveal extraordinary human achievement long hidden beneath the surface. Archaeological investigations across the Stonehenge landscape have uncovered compelling evidence supporting the new theories about construction and transportation. Detailed surveys of the surrounding plains and quarries reveal subtle depressions, ridges, and aligned post holes, which suggest that the builders modified the environment to facilitate movement. Some of these features, initially thought to be natural erosion, now appear to be deliberate trackways or support structures for transporting and erecting the massive stones. Excavations at the Preseli Hills quarries have uncovered tool marks on the bluestones, indicating careful shaping and controlled fracturing techniques. These marks suggest that Neolithic workers were not merely breaking stones randomly. Instead, they employed systematic methods to create shapes suitable for transport and precise placement within the monument. Experimental replications confirm that such methods, when combined with coordinated human effort and rope systems, could produce manageable stone blocks ready for long-distance transport. Additional evidence comes from the arrangement of stones within the monument itself. Surveys show that sarsens and bluestones were not positioned arbitrarily. Their spatial orientation aligns with specific solar and lunar events, implying advanced observational skills and careful planning. The precision of these placements, measured in fractions of degrees, suggests a combination of ritual intent and practical knowledge. The alignment patterns indicate that the builders understood geometry weight distribution and leverage sufficiently to erect stones with astonishing accuracy without modern instruments. Remnants of wooden structures potentially used as supports or rollers have also been discovered in the vicinity of transport paths and within the monument itself. Charcoal samples and traces of organic material embedded in soil layers provide insight into the types of wood employed and the techniques used to reinforce pathways or construct temporary frameworks. These findings corroborate experimental archaeology results, reinforcing the idea that prehistoric builders integrated environmental management with mechanical innovation. Moreover, LiDAR and geophysical surveys have revealed previously unrecognized stone pits and channels that may have been used to maneuver or stabilize the sarsens during lifting and placement. These features, combined with the topographical advantages of nearby hills and slopes, suggest a highly strategic approach, leveraging natural terrain to minimize effort and risk. Each archaeological layer, each groove or pit tells a story of meticulous planning, empirical engineering, and social organization, collectively painting a picture of a society capable of executing monumental projects with sophistication previously uncredited to Neolithic communities. The construction of Stonehenge was not simply an engineering feat, it was a monumental social undertaking that reflected the complex organization of Neolithic communities. Moving and erecting stones weighing up to 25 tons required the coordinated effort of large groups, likely divided into specialized teams. Some were responsible for quarrying, others for carving, preparing transport pathways, and guiding the stones using ropes, rollers, or levers. Elders and skilled craftsmen oversaw the process, ensuring that knowledge of technique, timing, and environmental conditions was transmitted accurately across generations. This demonstrates that social hierarchy and intergenerational knowledge played a crucial role in the execution of such projects. Oral traditions and ritual practices likely structured these efforts. Synchronized chants, rhythmic commands, or other ceremonial observances would have helped coordinate large groups of workers, maintaining both morale and precision. These cultural elements served as natural metronomes, allowing participants to exert force simultaneously and maintain the delicate balance required to move massive stones without toppling. The integration of ritual and engineering suggests that the society viewed labor and spirituality as inseparable, blending practical problem-solving with cultural and religious imperatives. The distribution of labor was likely strategic. Certain groups focused on quarrying and initial shaping of stones, while others prepared pathways, constructed temporary support structures, or managed the ropes and pulleys necessary for controlled movement. Coordination over long distances required communication and logistical planning, ensuring that large numbers of people could operate in harmony. Archaeological evidence, including post holes pathway, remains, and traces of temporary wooden structures supports the notion of deliberate social planning, emphasizing that engineering challenges were met with organized community effort. Stonehenge construction also had profound ceremonial significance. Many movements of stones and phases of construction appear aligned with seasonal and celestial events, such as solstices and lunar cycles. The integration of astronomical observation into construction suggests that labor organization, ritual timing, and technical execution were deeply intertwined. This coordination would have required an understanding of natural cycles, careful planning, and disciplined execution, highlighting the dual role of workers as both engineers and participants in sacred ceremonies. In essence, Stonehenge represents a fusion of social organization, ceremonial practice, and technical mastery. The builders were not merely craftsmen, they were problem solvers, planners, and coordinators working within a cohesive societal framework. The monument exemplifies how cultural priorities, spiritual beliefs, and empirical knowledge can converge to produce achievements that are both technically sophisticated and symbolically profound. Stonehenge therefore stands as a testament to human ingenuity, cooperation, and the enduring power of cultural expression. Taken together, the archaeological, experimental, and cultural evidence presents a compelling picture of the builders of Stonehenge as highly skilled, organized, and innovative. The movement and erection of massive sarsens and bluestones required not only physical strength, but also sophisticated understanding of leverage, friction, and terrain. Coordination of large groups through ritualized chants, synchronized effort, and social organization ensured that monumental stones could be transported and raised with remarkable precision. The careful alignment of stones with solstices and lunar cycles further emphasizes that Stonehenge was not a random assembly of rocks, but a carefully planned monument integrating engineering observation and cultural meaning. Yet many questions remain. Were there additional now-lost techniques to enhance efficiency? How did knowledge of astronomy influence construction decisions? Each discovery invites further exploration, demonstrating that the builders combined empirical problem-solving, environmental adaptation, and ceremonial purpose in ways that continue to challenge and inspire modern understanding of Neolithic ingenuity.